All right, so what we're going to do here is go ahead and do a little review before a quiz that I'm going to have you guys take. And so we're looking at some different quadratic stuff, some solving equations symbolically, some solving with graphing and tables, and also some working with changing forms of equations. So let's try this first one here. So we've got some symbolic SAD-MEP type problems here where we are solving for x using our reverse order of operations. And so you guys know how to do this. Let's go ahead and get it done. So we're going to first undo any subtracting or adding. So we're going to undo the minus 6 by adding 6 to both sides. Bring down what's left. We got 3x squared equals 12. And we'll go ahead and undo the multiplication of 3 by dividing both sides by 3. Bring down what's left. We've got x squared equals 4. Now we take our exponent step, remember, to undo squaring. We'll go ahead and take the square root of both sides. Let's do that in blue. So square root of both sides. So that cancels out the squared term. We'll bring down what's left. Then we're taking the square root of 4. The principal square root is positive 2. But we also have a negative square root, negative 2. So x equals 2 or negative 2. 2 and negative 2 would be the two solutions. So x equals 2, x equals negative 2 would be the two solutions to the equation. Same process with problem number 2. A little bit longer problem, so let's go through our order of operations. We'll start off by undoing any subtracting or adding that we see first. So we'll undo the plus 7. Remember, the minus 8 is inside the parentheses, so that's the last thing we'll take care of. So we've got to take care of the plus 7 on the outside of the parentheses here by undoing it from both sides. Bring down what's left. 2 times x minus 8 squared equals 18. Remember, we don't really do distributive property until we've multiplied this out. So the SAD-MEP order of operations, we really want to undo that 2 in front of the parentheses. That 2 is being multiplied by the parentheses. So we're going to divide both sides by 2 then. Bring down what's left. X minus 8 squared equals 9. All right, now we're at our exponent step here. We can't get into that x minus 8 until we have undone that square term on the outside. So this is when we take the square root. So that simply cancels out the squared term. We bring down what's left. You can keep the parentheses or not. It's up to you. I'm just going to keep the parentheses for now. I don't really need them. But just because the parentheses is our last step in the order of operations here, I'm just going to keep it there. Square root of 9, remember, is 3 or negative 3. Whenever we take the square root, that's when we've got the positive and the negative. Except for this time, we're not quite done with the problem because we still have the minus 8 inside the parentheses here. So now we can undo that subtracting of 8 by adding 8. Remember to add 8 to both of the 3 and the negative 3. So we have two solutions. 3 plus 8 is 11. And negative 3 plus 8 is 5. So x equals 11 and x equals 5. Are the two solutions. Okay. So that's solving symbolically. We also talked about how to solve an equation just using the graph. So pictured here is the graph of y equals 1/2 x squared minus 2. And to find the solutions, we're looking at when does that graph reach a y value of 6. You'll notice that the y value is being replaced with the number 6 in this first equation. So we're looking at, when does this graph reach a y value of 6? Okay, so y value of 1, y value of 2, 3, 4, 5, 6. So here's 6. When does the graph reach that? So let's draw a line across at y equals 6. This is our y equals 6 line. And we see that the graph crosses that line twice. It crosses it right here, and it crosses it right here. So notice that the graph crosses that at the point 1, 2, 3, 4, 6. So that's the point 4, 6. And this point over here is negative 1, 2, 3, 4, 6. So negative 4, 6. So when it asks for a solution, we already know the y value is 6 because that was given for us. So what are the two x values that are given for the solution then? Well, x equals positive 4 and x equals negative 4 are the two x values which produce a y value of 6 in the parabola. So those are our two solutions. Now let's do the same thing for the next equation. Notice it's the same graph, same equation here, only now we're looking at when does that graph reach a y value of negative 4. All right, so negative 4 on the y-axis would be going from 0, 0 down, negative 1, negative 2, negative 3, negative 4. So here's negative 4. So let's draw a line across at a y value of negative 4. And does the graph ever cross that line? You notice here's the graph. Its vertex is right here at negative 2. It never gets down to a y value of negative 4. Right? So no matter what x value we put into this equation, no matter what x value we put in here, it will never produce a y value of negative 4. So remember what that means is that there is no solution. Moving on to problem number 4, we use a similar idea here, only we're looking at the table. Here's the equation, y equals x squared minus x, and here's the table of values that is produced. We look at the equation down here and we notice that the y value is being replaced with a value of 2. So now we look on our table and say, okay, well, when is the y value 2? Kind of like when we said, when is the y value 6? Or when is the y value negative 4? When is the y value 2? Well, the y value is 2 right here, and again right here. Just like is oftentimes true of quadratic equations, since it has that U shape, it comes down through a value and then often comes back up, or comes up and then back down, so there's oftentimes two solutions. So the two solutions would be the corresponding x values that would produce a y value of 2. So the two solutions are x equals negative 1 and x equals 2. These two numbers right here and here. So those are our two solutions. All right, next one. When does that graph reach a y value of 4? You'll notice that we don't see a y value of 4 on here, but you'll notice that we know it crosses over 4 between 2 and 6, and between 2 and 6. So for the purposes of this little exercise here, we're just going to kind of estimate that it's going to reach 4 about halfway in between here and here. So at negative 1.5, and about halfway between here and here, and between 2 and 6, so positive 2.5. Now those are not going to be the exact solutions, so I'm going to say approximately equal to. And if we wanted to narrow down our table even more, use our calculator table and plug in that equation and see if we could get closer and closer to the actual solution. But for the purposes of this, we're just going to kind of estimate what it is. So about negative 1.5 and about positive 2.5.